Algebra can feel like this whole other language sometimes, right? Like a code we're trying to crack. Well, today's deep dive is all about unlocking that code, diving into the world of algebra, and hopefully making it a little less mysterious along the way. We'll be using your source, 11, algebra.pdf, to guide our exploration.
I think a lot of people hit algebra and just kind of freeze up like it's this big, scary math
Oh,
monster.
totally. But this source doesn't jump right into equations and formulas. It starts with this interesting connection between numbers and shapes.
Right, because at its heart, algebra is about building bridges between those two worlds. Arithmetic, where we're working with numbers, and geometry, the land of shapes and patterns.
It's almost like algebra gives us this secret language to talk about those connections in a way that numbers alone just can't quite capture.
Completely.
So instead of just saying, okay, I used 6 matchsticks to build 3 L shapes, algebra steps in and says, hold on, there's a rule here. We can use a variable to figure out the matchsticks for any number of L's.
You just hit on a key point there, variables. Those letters that tend to make people nervous.
Let's talk about those because the source uses a really cool example with matchsticks to explain them.
Right. We've got Amina and Sarita, and they're building those little L shapes with their matchsticks.
2 matchsticks per L, simple enough when you're just building a few.
Exactly. But imagine they want to build a whole bunch, or maybe they don't even know how many L's they want yet. That's where algebra swoops in with this elegant solution.
It's like algebra can see the future of our L-building endeavors.
Okay.
Okay, I'm intrigued. So how do variables help us out here?
Well, the source introduces n as our variable. N can stand for any number of L shapes Amina and Sarita decide to build.
So it's like n is this shape-shifting chameleon of a number adapting to whatever our L ambitions are.
Exactly. And here's the cool part. Instead of counting matchsticks every time, they can use the rule. 2 times n equals the total number of matchsticks they'll need.
It's like a magic formula for matchstick masterpieces. So if n is 5, they know they need 10 matchsticks. If n is 100, boom, 200 matchsticks.
Precisely. And that, my friend, is the beauty of variables and general rules in algebra.
It's like having a blueprint, but for relationships between numbers.
Think about building a fence with a repeating pattern.
Oh, good example.
Algebra just handed you a formula to calculate the materials you need, no matter how long that fence is going to be.
It's practical. I like it.
Oh, it gets even better.
Does it?
The source doesn't just stop at making patterns. It goes on to show how these variables are lurking in all sorts of everyday situations. Like, remember the example with buying notebooks?
Oh, right. They use the variable m to represent the number of notebooks.
Exactly.
And if each notebook costs 5, you can figure out the total cost no matter how many notebooks someone's buying. It's like having a secret code for understanding costs. 5 times m.
And how about that Republic Day drill with all those students lined up?
Oh, yeah. Rows and rows of students. So how does algebra make sense of all those neatly arranged students?
They use the variable r for the number of rows.
Ah, so we've got R representing our rows of students.
And no matter how many rows they decide to add or take away, that expression 10 times r still holds the key to figuring out the total number of students in the drill.
It's amazing how these little variables can represent something so big and complex.
And what's really cool is that we can build those expressions, those combinations of variables and numbers, even before we know the exact value of the variable.
It's like algebra lets us create a model of the situation, a kind of framework for understanding how things are connected.
Right. Like that marble comparison with Sarita and Amina.
Ah, yes. Sarita, always the marble mogul, right?
They use x to represent how many marbles Amina has. Sarita, of course, has more.
Naturally.
10 more, to be exact. So suddenly, we've got x plus 10 to describe her impressive marble collection.
Simple, but it paints a clear picture.
Right. And they do something similar with ages, comparing Bolu and Raju by 3 for Balu, always trailing behind Raju's x.
It's fascinating how these seemingly simple expressions can capture relationships that are always changing.
Exactly. That's the beauty of it.
This whole conversation is making me think about all the everyday scenarios where we're using this kind of thinking without even realizing it.
Oh, absolutely.
Like when you're figuring out how much gas you'll need for a road trip, or, I don't know, maybe you're baking cookies for a bake sale and need to adjust the recipe, or even just splitting the check at a restaurant.
Right. Algebra is like this secret framework for approaching problems big and small, even if we don't always stop to think, aha, I'm using algebra right now.
It's like it's woven into the fabric of how we solve problems. Speaking of solving problems,
What about it?
what about our friend Apu from that matchstick example? He's still waiting to find out how many L's he can make with those 10 matchsticks.
Ah, yes. Apu. His curiosity leads us to the world of equations, a concept you're probably already somewhat familiar with, even if you don't always love them. Remember that equation from the source, 2n equals 10.
Okay, so we're on a mission to find the exact number of L's represented by our trusty variable n that'll make that equation true.
And what the source wants us to remember is that an equation is all about finding that value, the one that brings both sides into perfect balance, beautifully united by that equal sign.
So an equation is like a balancing act, trying to find that perfect equilibrium.
You got it. And those inequalities with their greater than and less than symbols, they're like, we don't need no perfect balance. We're just here to shake things up a bit.
The rebels of the math world. Okay, but going back to our matchstick mystery, 2n equals 10, how do we actually solve for n without resorting to building L's with our own matchsticks until we stumble upon the answer?
Well, the source starts with a method you're probably familiar with, trial and error. Remember that table they used to test out different values of n?
Yeah, it's like, okay, what if n is 2? Does that work? Nope. Okay, what about 3? It's a bit like guessing, isn't it?
It is, and just like searching for a lost key in the dark, you might eventually find it, but it's not exactly efficient.
Right. There's got to be a better way, a flashlight for our equation solving. And I think the source hints that there are, more systematic ways to solve equations.
Definitely. This deep dive is just a little taste of the world of algebra. There are entire branches of math dedicated to cracking those tougher equations, no matter how complex they get.
Whoa, okay, now I'm kind of curious to see what those algebraic adventures might hold, but before we go down that rabbit hole, I have to ask you about something I found fascinating in the source.
Go for it.
The history of algebra, it goes way back, right? Like over 3,000 years.
It's pretty mind-blowing when you think about it. Just imagine those ancient Egyptians trying to wrap their heads around the idea of an unknown number, coming up with symbols to represent it.
It's like they were creating a whole new way of thinking about math.
Exactly. And it wasn't just the Egyptians. The source highlights the contributions of Indian mathematicians, too. Names like Aryabhata and Brahmagupta. They were using letters for unknown centuries ago. Even had a word for algebra, Bijaganit.
I love that. Bijaganit. It has such a ring to it. It makes you realize that this isn't some dusty old subject that's stuck in textbooks. It's a living, breathing part of our intellectual heritage.
Absolutely. And what's really cool is that it connects us to those mathematicians across time and cultures. When we're wrestling with an algebra problem today, we're engaging with ideas that have been pondered for millennia.
It's humbling in a way, isn't it?
Yeah.
To be part of that long lineage of mathematical exploration.
It really is.
And, it kind of makes those algebra problems from school seem a little less daunting.
I like to think so.
It really puts things in perspective, doesn't it?
It does.
Like, we may not all be using algebra to, build pyramids or decode ancient manuscripts,
Look.
but this deep dive has been such a great reminder that algebra, it's so much more than just memorizing those formulas or solving for x.
It really is about patterns, about understanding relationships between things, and then using that knowledge to solve problems, whether they're big or small.
Exactly. It's like having this new lens to view the world through.
I like that. A new lens.
And sometimes it's not even a conscious thing, right?
Totally.
It's like you're going about your day, figuring out how much paint you need, or, trying to double a recipe, and suddenly you realize...
Algebra.
Exactly. It's like, wait a minute, I'm using algebra right now.
It's there behind the scenes, making our lives a little easier, a little more efficient.
It's like a secret superpower we didn't even know we had.
And the best part is, we've only just scratched the surface here. Remember, the source mentioned there are even more streamlined ways to solve equations.
Oh, right. Like a whole other level of algebra mastery.
Exactly.
So much to explore.
There really is.
Well, for anyone listening who maybe broke out in a cold sweat when we said the word algebra at the beginning of this, what would you say is the most important thing to remember from this deep dive?
Don't be afraid of it. Embrace the power of algebra. Those variables, equations, they're not your enemies.
And are more like tools, right?
Exactly. Think of them as tools that can help you unlock patterns and solve problems, make sense of the world around you.
I love that. It's like instead of being intimidated by algebra, we can choose to be intrigued by it.
Exactly.
And who knows, maybe even a little bit excited about it.
I'd say so.
Well, on that note, I think it's time to wrap up this deep dive into the fascinating world of algebra.
I agree.
We hope you've enjoyed exploring with us today. And remember, keep those minds curious, because there's always more to discover. Until next time.